S-Chan presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
In part 1, we did half range sine and cosine series, and in part 2, I am taking examples to explain you how we are finding sine and cosine series. Hello everyone, I am Dr. Seema Thakran. Welcome to S-Chand Academy. If you want to learn engineering mathematics, please refer to the book by S-Chand Publishing. The e-book link is given in the description box below. So let's take up one example, and example is find the sine and cosine series of fx equal to mod x in the interval So the thing is that function I have taken, and you can clearly see if the interval is half, it is understood that the question is of half range, but anyhow it is mentioned that you have to find sine and cosine series. So for the solution, everybody knows, or we have also done in our previous lecture, that mod x is even function. So it means if I write it x in the interval 0 to pi, it's just the same thing. So it means this is given to us, and if we are writing sine series, first we will write sine series, and for sine series we know sine series. For sine series only what we have to calculate? Bn only, and Bn is 2 by pi 0 to pi fx sine nx dx. This is the formula. Here a0 and an will be 0, because for series of sine the function will be odd. So fx is x. Now I am calculating the series. This is my bn value. Bn value I am calculating. So it is 2 by pi 0 to pi x sine nx. So 2 by pi, because product of two functions, eyelet rule will be applying. So first and second, x sine nx is integration is minus cos nx by n, minus derivative of first and minus, then it will become plus cos nx by n dx. There is no, I'll apply as usual the limit later. So minus x cos nx by n plus integration of cos nx is sin nx upon n square, and now I'll apply because my integration is done. So 2 by pi minus pi by n, cos n pi is minus 1 to the power n, this will be 0, and for 0 it will be completely 0. Pi will get cancels, minus 2 by n minus 1 to the power n, and this is my Bn. Anyhow, the question for this will be short, because for odd function it will be short, only Bn we are supposed to calculate. Now I am writing the Fourier sine series or series of sine will be summation Bn value sin nx. So summation minus 2 by n minus 1 to the power n sin nx, and this is my fx. Expand it because n is varying from n from 1 to infinity. You will see exact series how it will look. So for 1 it will be 2 sin x. 2 I am just writing outside. So then for 2 it will be positive. So minus 1 by 2 sin 2x. Then for 3 it will be plus 1 by 3. This is the series. and so on. So this is the series and you can define the sum at different points, and now I am calculating series of cosines for the same function. So my fx was mod x, but it will be x only in the interval 0 to pi, and series of cosines is a naught I will calculate and an I will calculate. A naught will be 2 by pi. In all the three formulas you can see I am just the formula is twice because of the even odd concept, and this is my A naught, this is my an. Now my function is x, extension will be according to even concept. So A naught will be 2 by pi 0 to pi x dx. It will be 2 by pi square by 2, because x integration will be x square by 2, and then when you will substitute the limit it will become pi square by 2. So 2 get cancelled, pi only. Then now A naught, an sorry. So 2 by pi 0 to pi fx cos nx. I just substitute the value of fx and that is x. So 2 by pi, first the same integration of cos nx is sin nx upon n minus 0 to in limit will apply later. So first ka derivative, then cos nx integration is sin nx by n dx. So 2 by pi, and now okay, one more step. Sin nx integration is minus cos nx, so it will become positive, and by n square 0 to pi. Sin n pi is 0, so but cos n pi is not 0, so the value will be 2 by pi minus 1 to the power n upon n square minus, when you will substitute 0, it will become 0, and minus because 0, so 1 by n square. This is the value of AAN. Now I just when it will be odd, it will be minus sign. When n is odd, the value, complete value I am calculating. So it will be minus 2 by n square. So it means finally minus 4 by pi n square, n is odd, and 0 f n is even. Because for even this value will become positive, so 1 by n square minus 1 by n square will be 0. So finally we write now the series of cosines is given by fx equal to a naught was pi, so pi by 2 plus summation this value minus 4 by this cos nx, and this is for odd only, so n is odd. You will not substitute it even value because there is no point, and now I am expanding it, only putting the odd values. So minus 4 by pi, 1 I am substituting, so it will be 1 square cos x, then 3 I am substituting, and so on. So take out minus 4 by pi outside, and inside it will be cos x plus cos 3x plus and so on. And this is my fx. Now if you see, okay, this is 1 square, this is 3 square, and the next term will be, if the question was fx equal to this in the interval this. The importance of half range or Fourier series you will see now. What I am doing, this function is continuous. At x equal to 0 the function is continuous. It means x equal to 0, at x equal to 0 the function is continuous. Therefore, the sum at x equal to 0 will be f0, and you can see f0 is 0. Now, this is my final, this is the series, Fourier series, and using this Fourier half range cosine series, let's see how we are getting the sum. So, 0 equal to, what to do? 0, put 0 here and 0 on the RHS. Pi by 2 minus 4 by pi, 1 by 1 square, because cos 0 will be 1, and 1 by 3 square and 1 by, keep writing. So, take it to this side, pi by 2, and then divide it. So, it will be, it is 4 by pi, so it will become pi by 4, and 1 by 1 square and 1 by plus 1 by. So, the sum is pi square by 8. Can you see, till now you haven't got the sum, any formula which can give you the sum of this type of series, and you by Fourier series we are able to write the sum of this series, not directly we got it. First we write the Fourier series of fx equal to mod x, the sine series and cosine series. Then at a point that is 0, we have written the sum concept, and sum concept says that it, because this point is continuous, so sum will be f0, 0 and 0, and on the RHS also when I am taking x equal to 0, I am getting this particular series sum, and that is simply pi square by 8. That has come only by Fourier series concept. Till now you haven't got any this series sum, in not even like you haven't learned it or you haven't seen anywhere. So, this is given by Fourier series. So, you can see that Fourier series gives you a very difficult series sum, and there is no other series which can define this sum. So, this is very important series, and there are other series or with the help of other examples also you can see that how important the Fourier series is. So, in this lecture we have learned half range sine series, cosine series. One thing is important, that the interval will be half, but we extend the function in a particular way that it becomes odd or even accordingly, and so that we can get the sine and cosine series. And some important, the very important fact about Fourier series is that it gives you difficult series or the series which are very important for us, and the series sum we can see, and that is only by Fourier series. If you want to learn engineering mathematics, please refer to the book by S. Chand Publishing. The ebook link is given in the description box below. If you like the video, please do like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.